opposite, children, of squares is square roots. And those look like this. Okay, and just to tell you what these things are, this little thing that looks like a division sign, but it is not, okay, is called the radical sign. Okay. This guy inside here is called the radicand. And sometimes you will see a little number up here. Okay. There could be a 3, there could be a 4, but when there is no number up there, it's an assumed 2. Okay, and when it's an assumed 2, that is the square root. Okay, you won't see the 2 there, but you might, sometimes you'll see a 3 and that's a cube root. But today we're specifically just talking about square roots. So you won't see that there, but it's called the index number. Okay, and what the square root sign asks you is this question. What number times itself gives you the radicand? Okay, in other words, if you have the square root of 16, which this is, okay, that means what number times itself, these have to be the same number, will give you 16. Okay, and roots, that would be 4. So the answer to this, the square root of 16 equals 4. That is the answer to it. You don't put 2 4s down, you just put 1 single 4 down. Okay. The square root of 81. What same number times itself gives you 81? Kelvin. 9. The square root of 100. AJ. 10. The square root of 18. Samantha. Michael? 4.5. Negative. Christine?
9.
No. 9 was the square root of 81, remember? What same number times itself gives you 18? Well, children, you've just hit upon, when you get a number like this, okay, this is what we call an irrational number. If you go to a calculator, which is probably the best way for somebody to do this, and type that in there and tell it to find the square root of 18, you will get a decimal number that never ends. Okay, that's what makes it irrational, and pi is one of those. Square roots that don't work out evenly, okay, like these, end up being what we call irrational because they don't ever work out. They're a long decimal number that goes on forever and ever. Now, I say that because you will hear people talk about the perfect squares. And when they talk about perfect squares, they're talking about the numbers that actually do work out. Okay? Are the numbers that have exact square roots. And there's not, when you think of all the numbers in the world, there's not that many ones that really work out. And you know them because you can just go through and multiply. You could have 1 times 1. 1 is a perfect square. 2 times 2, which is 4, is a perfect square. 3 times 3 is 9, it's a perfect square. 4 times 4 is 16. 5 times 5, 6 times 6, 7 times 7, 8 times 8, 9 times 9, 10 times 10, 11 times 11. Any other number that falls in between there is going to be what we call irrational because it won't work out. If I did the square root of 50, it doesn't work out. Okay, it has to be a square root of one of these numbers or bigger to work out. Okay, so this is an irrational number. We don't like to deal with it. The book won't give them to you. But all of these are what we call perfect squares because they do work out. And we like things to work out, so it's nice to be a perfect square. Like such as that. Ooh. Bam. And I believe that's, ladies and kids and gentlemen, and people of all ages.